everybody. We're going to go over the practice for 4-3. And again, this is the community property. And let's read through the directions. So the first directions say, write a multiplication sentence for each array. And we've been doing this for some time now, where you count how many rows. So in this case, 1, 2, 3. And then you need to count how many are in each row. 1, 2, 3, 4, 5. Now, we found out by watching the video and by doing the reteaching that there are actually two ways that you can do this problem. I'll let you go ahead and put the product down, but remember that it doesn't have to be 3 times 5. You can use the community property and flip-flop these numbers around. So a possible answer could be 3 times 5 or 5 times 3. So what you're going to do is you're going to do the same on 2 and the same on 3. You know how many rows and then how many individual circles are in each row to find out your multiplication number sentence. Same on number 3. How many rows are there? And then how many individual circles are in each row? Now, down, we're going to go to number 4 and 5. And on 4 and 5, you're going to draw an array to find each multiplication fact and write the product. Product, remember, means answer. So I kind of started doing this one. And again, you all can be a little bit more precise than I am because my cursor's not the best. So I have 1, 2, 3 rows, and I have 1, 2, 3, 4, 5, 6 in each row. So I can figure out, I can count by 6s, or I can individually count. I have 6 there, 7, 8, 9, 10, 11, 12, and so on. Okay, you can do it like that if you'd like to too. But you're going to put your product up here after the multiplication number sentence. You're going to do the same on number 5. You're going to do the array over here. 4, so you're going to have 4 different rows. And in each row, you're going to have 7. And you're welcome to do the X's as I did, or do circles. Whatever shape you'd like to choose, as long as the lining up is pretty precise so that we know, oh, that's an array. Down here, number 6 through 11, these all go together. So you're going to complete each multiplication number sentence, and you can use counters or you can draw an array to help you. If you notice, I made these kind of like weird little red squiggles between these two number sentences. And the reason why I did that was because if you notice, there's a pattern going on here. So we have some community property going on or some flip-flopping with numbers going on. So if you have 3 times blank equals 21, and you have a 7 times blank equals 21, then you're really going to be using those numbers to help you out with both problems. So 3 times 7 equals 21, which I got it from down here. And then I bet in this problem, we're going to take the 3 and bring it down because 7 times 3 is 21. So that's kind of a trick with some of the problems, not with all of them. But I guess just for this problem. But the other problems, you're going to have the same answers. Because if you notice, 4 times 9, 9 times 4, the products are going to be exactly the same as one another. Same, 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 same. They just flip-flopped the numbers, the factors around. Number 12 is an explain it. If you know that 7 times 8 is 56, how can you use the community property, order property of multiplication, to find the product of 8 times 7? Well, we just talked about it up here. Because here's 6 times 8, 8 times 6. Why did I put that red line there? Nudge, nudge, wink, wink. Something about the products being the same. So use that knowledge to help you. Go ahead and write in your explain it. Why, if you know that 7 times 8 is 56, how are you going to find the product to 8 times 7? Okay. If you're still stuck and you're having problems understanding it, bring it into your teacher and we'll go over it again so that you have a better understanding.